If there are no questions on any of the homework assignments, we're going to start today's lesson over rotations. So we're going to be talking about rotations about a point. So we're talking about rotations, and mainly we're going to be rotating points about the origin, 0, 0. We're not going to worry about rotating about a different point other than the origin. And the main reason for this is because if I were to rotate something other than the origin and other than 90 degrees, we would need a protractor and a compass to be able to actually do this, and a straight edge, really. But we're going to mainly focus about rotating about the origin. And now when it says a normal rotation, so on the homework, if it just says to rotate something 90 degrees, 180, or 270, it's talking counterclockwise. The understood method of rotation in mathematics, if it's just given a degree, is always counterclockwise. We're always going counterclockwise. So if it's not stated, it is counterclockwise. Now, there's a set method for how we do this. So if I rotate a point A, B 90 degrees, what we do is we take that point A, B, we flip A and B and make the first negative. So A and B flip, and the first term is now negative. Well, for 180, I take A and B, and I just make both of them negative. And for 270, well, we flip it and make the first one positive. The second one is negative, because that's what they told us on there on the sheet, yes? Now, for a rotation of 90 degrees, let's actually delve into this, because we have these three here. So if we mainly look at a rotation of 90 degrees, we flip A and B and make the first negative, yes? That's 90 plus 90. 180. So if I rotated this 90 degrees again, I would get to 180, yes? Because 90 and 90 is 180. And so what did I do for 90? I flipped them and made the first one negative, yes? So if I flip them, the second term would now be negative B, yes? A would go to the front and become what? Negative, yes? Because we flip it and make the first negative. You know what or pretty much what it told us for 180? So we're taking that same method, flip it, make the first negative to get to 90. We do it again to get to 180. If I want to get to 270, well, I would do it again, yes? Which would mean negative A would go to the back. But B moves up front. Well, it's already negative. And if I make it negative again, well, a negative and negative make A. So I get back to B. What happens if I do another 90-degree rotation? 360. It'd be 360, yes? So if I flip this again, B would go second, yes? The negative A would move up front, and we would make it negative. Well, negative and negative make a positive, so I'm at A, yes?
Skateboarding uses this kind of stuff.
So 360, you would get back to where you started, yes? So that's counterclockwise. Well, if I went clockwise, wouldn't 90 degrees clockwise be the same as 270 degrees counter? Because what is it? One whole circle is, so 270 one direction, 90 the other direction would be 360, it'd be a whole circle, yes? So it works out for counterclockwise. Really what we're doing is similar to clockwise. I'm going to flip A and B. But when we did it counterclockwise, we made the first one negative. What do you guys would guess going counterclockwise? We would make the second one negative. So for clockwise, 90 degrees, well, we could say A comma B is going to become B comma negative A. 180 degrees, well, that'd be A comma B is equal to negative A comma negative B. What? Yep. If it's not stated, it's understood to be counterclockwise. Out of all of these rotations, which one ends up being the exact same? Well, 360, and there's one other. 180. Because if I turn 180 halfway one direction, it'd be the same as turning halfway the other way. So 180 actually works out, counterclockwise or clockwise, you'll end up at the same location. 180 doesn't really change much. Yes? So any questions on this here? Because all of this is really going to hinge around these here. Or really, we could stick, well, that's a little high, with these two here. The fact that clockwise, counterclockwise, so clockwise is taking A, B to B, comma, negative A. And the counterclockwise is taking A, B to negative B, comma, A. Because if I use that one motion, that one flip, I can get any of these three. Because it's just repeating that move multiple times. So if I want to rotate this point here, 4, 3, a rotation of 90 degrees counterclockwise. So in all of these, we're flipping them. If I'm just doing groups of 90, I'm flipping it, and I'm making one of them negative. So for counterclockwise, we would flip it. So 3 would go first, 4 would go second. Now, it would be negative 3, because for counterclockwise, we're making the first one negative. We flip it, make the first one negative. For clockwise, we flip it and make the second one negative. So have I rotated it the complete 90 degrees counterclockwise? Well, yes. We're done. CCW is counterclockwise. Counterclockwise, CCW. CW is clockwise. So negative 2, 9. Rotated 270 degrees clockwise. So if I go in groups of 90, how many times am I going to have to do this? 2 or 3 times, because we've got to do it once. So if I do it once, I'm at 90. I do it twice, we're at 180, and I do it a third time, we're at 270, yes? And that's where we want to be. So I'm going to flip these. So 9 would go first, negative 2 would go second, yes? And which one do we make it negative, since we're going clockwise? We make the so it would be 2, because we make the second one negative for clockwise. Because we flip it in either way. We still flip them, but with counterclockwise, we make the first term negative. We switch the sign of the first term. For clockwise, we switch the sign of the y term. Clockwise, we're switching the sign of the x after we flip it. Clockwise, we're switching the sign of the y. Well, that's just 90 degrees. So if I get to 180, I flip it again, which means 2 would go first, 9 would go second, and which one do we change? We would change the 9. Now, we could have jumped there because 180, as we saw, a comma b is equal to negative a comma negative b. Well, 2 started as what? Negative. So if I switch it, because negative, negative 2 would make it positive, yes? The 9 started out as positive. It's now negative. We switched both signs, didn't we? So essentially, we made this move here, yes? Let's do it one more time. So to get to 270, well, I would flip them again. Negative 9 would go first. 2 would go second, and we make which one negative? Change the sign of which one? The second. So that there would be our 270 degrees clockwise, yes? What would happen if I did the counterclockwise for this once? I would have taken negative 2, 9, flipped it, yes? In which the 9 would have become negative, yes? Wait, isn't that what we got? Because again, a whole circle is what? 360, yes? Well, if I turn 90 one direction, it's the same as turning 270 in the other. So again, let me get a different color than these two. Go with green. Because our 90 degrees counterclockwise is going to be the same as 270 degrees clockwise. 90 degrees counterclockwise is the same as 270 degrees counterclockwise. And then we have 180 and 180. So if I really wanted to, did I have to do this move 3 times clockwise? No, we could have done one move which direction? Counterclockwise. Because we can get to the same point, the same location. This is why a lot of times textbooks will never show clockwise. They'll just stick with counterclockwise because we can really get that direction. We can get it all with one. Negative 4/8 rotation, 180 degrees. Which direction are we going? Are we going counterclockwise or clockwise? Either or, it doesn't matter. So let's do counterclockwise first. So counterclockwise would mean I would flip it and make the first negative. So I move 8 up front and it would be negative, and I would have negative 4 second. 8 comes to the front and becomes negative. 4 goes to the back. We do it again. Well, negative 4 comes up front and becomes negative, which would make it what? Positive 4, comma, negative 8. And that's going counterclockwise. Well, if I go clockwise, negative 4/8, well, we would flip it and make the second negative, which would give us the 0.84. And if we do it again, we would get the 0.4, negative 8. Well, those two there are the same point, yes? That's it. Any questions on this here? Any questions on any of this here? Are we good with this here? Okay, pick 2. There you go. Do we need to see another example of any of these here? Yes? Okay. Let's look at the first one. That's fine. Negative 12/1. What are we doing? We're rotating it 90 degrees clockwise. So one thing we know for sure is that rotations of counterclockwise or clockwise will always involve flipping it. So 1 is going to come up front. Negative 12 will go second. We flip it. Now for clockwise, are we changing the sign of X or are we changing the sign of Y? Y. We're changing the sign of the second term because we flip it and the one that goes second, the Y spot, because we talk about a coordinate point, it's always X comma Y. So when I flip it for clockwise, I flip it and make the second one negative, the Y value negative. So here, the Y value was negative 12. So if I make it negative or I change it, it goes from negative 12 to positive 12. Because a negative and a negative make a positive. So this here would be 1 comma 12. Have I gone 90 degrees clockwise? Well, yes, because we only needed one move, because every time we flip it and change one of the signs, we're doing 90 degrees, either clockwise or counterclockwise. We're going one side or the other. Any questions on this here? $270 degrees counterclockwise. Well, that would require how many moves? 3 if I'm going counterclockwise. Is there an easier direction to go? How far? 1. Because 270 plus 90 is 360. So let's go counterclockwise, just so we can see it. So if I'm going counterclockwise, we flip it. So negative 49 would go first, and 12 would go second. And are we turning the first one or the second one negative? We're changing the sign of the first one or second. We're changing the sign of the first term, yes? We're making the 49 negative. Because we flip A and B and make B negative. Well, B was in the second spot. It's now in the first. And we make it negative, or really we change the sign, which would make it positive 49. So that's 90 degrees. We want to get to 270. So we do it again. So we flip it. 49 would go into the second spot. 12 would go up front. And we change the sign of the term in front, which would take it from positive 12 to negative 12. We have to do it one more time. You don't need the comma. Well, the negative 12 would go in back. 49 would come out front, and we have to change its sign, which would make it negative. So we get negative 49 comma negative 12. Because if we went clockwise, we would get right here, because we would flip it and make the second negative, which would make the 12 negative, and we would have negative 49, negative 12. Questions on this here? Are we good with this here? Yes? Okay. Let's look at the last one here. So we can go counterclockwise. So counterclockwise would be flipping it and making the first negative. So if I flip it, I get negative 8, 9. But since the first term is already negative, a negative and a negative would give me a positive. So it would just be 8, 9. Because a negative and a negative make a positive. Now that's just 90 degrees. We have to do it one more time. So I would flip it. So the 9 would go first, and the 8 would go second. And the first term, we would turn to negative. And that's it. Questions on this here? Any questions on any of this here so far? Are we good with all this here? Yes? Okay. Graph the quadrilateral RSTU with vertices 3, 1, 5, 1, 5, negative 3, and 2, negative 1, and its image after a 270-degree rotation. Now, it's probably hard to see on your graph, I realize that, after looking at this. But there should be 4 points already on there. I think once I drew that in, it's kind of a little bit easier to see where it's located, yes? So that's our starting points. Now what we're going to do is we're going to rotate it 270 degrees. Well, which direction? Counterclockwise, yes? So which direction is it going to go? It's going to go this way, yes? Okay. Now there's 2 methods to doing this. Caleb already found one. Is if I rotate this 90 degrees, which direction is it going? It's going this way, yes? So one thing you can do, and I can't do this because I'd rip something out of the wall to do it, but what you could do is if I could, I would take this and spin it. So, actually, let me get one of the note sheets. Because unfortunately, I'm going to pause this here because y'all can't wait, and I'm going to record this one because this one here I'm going to actually do on the paper. All right, so going 270 degrees, And which direction are we going? Because I don't think we ever answered that. Counterclockwise. Why is it counterclockwise? If it's not stated, it's always counterclockwise. If it's not stated, it's always counterclockwise. So let's start off with the point 3,1. Now, doing it the way we did it, the first point you graphed at 3,1 is now at what point? It would, because we're over, goes once, twice, 3 times, because now we're at negative 3, 1, or right there, yes? We're at negative 3, we're over 3 down 1. So let's see what happens. So if I do it first, counterclockwise, I would flip it and make the first negative, yes? For counterclockwise. I would do it again, which would give me negative 1, negative 3, yes? And if I flip it a third time, we get 3, negative 1. Isn't that where we put that 1 point when we rotated the page? Where it ended up? Because what are we doing? We're rotating about the axis, yes? And when I did it with the paper, I rotated the paper when we moved it 270 degrees and then plotted it because it's the exact same thing. Instead of rotating the figure, I rotated the page and stuck it back where it was. Because if you rotate the page and do that, we can't focus too much on what the values, the signs are. We treat it like a normal axis. This here works as well. This here works as well. I can take the second point, 5,1, and do the same thing. We flip it and make the first negative. So that'd be negative 1, 5. If I do it again, it'd be negative 5, negative 1. And if I do it a third time, it'd be 1, negative 5. 1, negative 5. Our first one was at 3,1. Yes? This one? Flipped it. Ah, yes. Thank you. I thought that seemed weird. What did I not do on the first move? I didn't flip them. That seems better. 1. Yeah, because I changed the sign, but I never flipped that first one. So any questions on these first two? Now that I have the first point actually correct. Are we good with these two here? Yes? Okay. Let's do it with the other two. 5, negative 3. So going counterclockwise again, we'll flip it and make the first negative, which would give us 3, 5. Again, we'll flip it and make the first negative, which gives us negative 5, 3. And if we do it one more time, we'd have negative 3, negative 5. Negative 3, negative 5. And the last one is 2, negative 1. So again, hopefully as I'm jumping through these, we're good with this here. Yes, I'm not losing anybody as I'm doing this flip and change, flip and change. Not a flipping change, but we're flipping and changing. Because again, we flip it, and the first one was negative, now it's positive. So we get 1, 2. If we do it again, we would get negative 2, 1. And lastly, we would be at negative 1, negative 2. And this is exactly what y'all got when we rotated the page. Let's see here. 90, 180, 270. 270, yeah. So it's 3, 1, 5, 1, and it should be that direction. So, yeah, and that's one of the things that's with rotating the page that's hard to grasp, is when you're looking at it and it says clockwise, you're going to be very tempted to rotate the page this direction, but it's actually rotating it the opposite direction. Because as I rotate the page clockwise, the graph itself is going counter. Okay? So if you have issues with the flip, the turning the page, just rotate each point. Because rotating each point will get you there. But rotating the page is just a shortcut to doing it. And you won't have a paper to actually do this on the homework, because you'll have your Chromebook. Which, if you're just doing 90 degrees, isn't bad. If you're trying to do 180, you'll have the thing upside down. Doesn't work as well. Any questions on this here? Is this any different than what we did for the first 6 problems? Well, no, it's just now that I have 4 points, or I have more than 1 point. So we're rotating 180 degrees, yes? Anybody have a guess at which quadrant we would be in? Quadrant 3. Is this here, we're starting off in quadrant 1, 2, 3, 4. Well, when we number them, which direction are we going? Counterclockwise. So we're going to start off in 1, 2, 3 is where we'll end up. We won't go into 4. So let's look at this here. So I can start off with the first point, 3, 1. And what do? We flip it and change the sign of the first if we're going counterclockwise. So if I flip it, I get negative 1, 3, and we change the sign of the first. So when we do the 90 degrees counterclockwise, it would be negative 1, 3. If I do it again, I get negative 3, negative 1. Let's see the next one, 3, 4. Well, at 90 degrees counterclockwise, it would be negative 4, 3. We flipped it and changed the sign of the first. And if we do that again, we would be at negative 3, negative 4. There's one side. Any questions on any of this here? Last point, 1, 1. Well, that would become negative 1, 1, which would become negative 1, negative 1. Any questions on any of this here? Are we good with this here? Yes? Any questions on anything we've done so far? Where's the one point that would never change its location when we rotate it? Because we said for reflections, if it's on the line of reflection, it doesn't move, correct? Here, it's almost the same principle, but what point are we rotating everything about? 0, 0. So if I have a point on 0, 0, it would never move. So that's the only point for rotation. Whatever we're rotating about, if there's a point on that point of rotation, it won't move. Let's do this one here. And we actually have 2 more after this. What we're doing. Okay. So this here, we're rotating 90 degrees about the origin. So we're rotating counterclockwise. Well, since it's just counterclockwise 90 degrees, we just have to do this once. So to do it once, we flip it and change the sign of the first, which would give me, can we have negative 0?
No, 0 stays
0 is not positive or negative. So 0, 3. All right, the next point starts at 4, 3. Well, I flip it and make the first one negative, so I would have negative 3, comma 4, negative 3, 4. Yeah. And lastly, we have 6, 0, which would be 0, comma 6. And since 0 cannot be positive or negative, it does not become negative. It's just 0. Questions on this here? Are we good with this here? Yes? Well, guess what we can do? Oh, go to the next page. Well, if we could do translations and reflections, so we could do reflections and rotations. We can do rotations and translations. We can do reflections, translations, and rotations. We can rotate, translate, then rotate. We can reflect, rotate, reflect, and then rotate. We can do any combination of these. So, now we're starting off with this line here. And we have 1, negative 3, and 2, negative 6. Now, what does it talk about first? We have a reflection in the y-axis. So reflection across the y-axis. So if I reflect it across the y-axis, so our line is right here, so I can count over to it. Well, this one first one's a distance of 1 away from it. So I go a distance of 1. So R is over here at R prime. Well, S is 2 away from the y-axis, so we go over 2 to get S prime. Any questions on this here? Are we good with this here so far? Yes? Yes? So R prime, when we reflected it across the y-axis, is now at negative 1, negative 3, yes? Would we agree with that there? S is now at negative 2, negative 6. Well, really, what did we do? We just changed the values of x from positive to negative. Any questions on any of this here so far? Are we good with this here? Yes? So we finished the first one. Now we want to rotate 90 degrees about the origin. So we're going which direction? Counterclockwise. Counterclockwise.
Wait, why is it -2 and -1 already?
We reflected it across the y first. Now to go 90 degrees about the origin, we flip it and make the first one negative. So negative 3 comes up front and becomes positive. We do the same thing for S. So the negative 6 comes up front and becomes positive. So our new line is going to be at 3, negative 1, and 6. Bless you. So that's our final location. Questions on this here? Order matters. Order matters for this here. Because if I rotate this first, 90 degrees, well, 90 degrees would put the line somewhere up here. Reflection across the Y would put it over here. So order matters for this one here. For reflections and translations, it didn't make a difference, but rotations does matter. Rotations are going to matter. Any questions on any of this here? Are we good with this one here? Yes? Okay. So, last one of the day. We're starting off with this line here. We're going to translate it and then rotate it 90 degrees. Yes, our first translation is going to be left 2 and down 1. So I'll take each one of these points and go left 2 and down 1. Here we're going to go left 2 and down 1. Any questions on this here? So what are our new points? Well, A prime is now at -6, 3. B prime is now at -3, 6. And once I graphed it, I can go on and just see what those coordinates are, X, Y. And what does it ask next? So we did this one. Now we want 90 degrees about the origin. So which direction are we going? Counterclockwise. So I would flip these and make the first one negative. -3, -6. Well, we would flip it. The -6 wouldn't change, but we would make the 3. Since it was positive, it's now negative. That'd be our A double prime. -3, -6. And our other one here, well, this one here is going to be -6, comma, -3. Since 6 was second, it goes up front, and we change its sign. Since it was positive, it's now negative. And move the 3 to the back. And that's it. Questions on this here? Are we good with this here? Yes?